All right, here's lesson 3, solving equations involving more than one step. So in order to solve multi-step equations, we need to work backwards from the order of operations, which means we look for addition or subtraction first and eliminate those numbers. And then we're going to work on the multiplication or division. So this first example, we have x being divided by 5 and being added to 12. The first thing we're going to work on is this positive 12. Because we're working with the order of operations in reverse, we deal with the addition. So to make a zero pair, we're actually going to subtract 12. And you're going to be left with x divided by 5 is equal to 2. Now to get rid of the denominator of 5, multiply by 5, and x will equal 10. And to check, you plug in what you've just solved in for x in the original equation. Well, 10 divided by 5 is 2, and 2 plus 12 does equal 14. So we've done it correctly. Here again, we're going to start with the adding of 9. So the inverse operation is to subtract 9. 6 minus 9 is negative 3. To get rid of the denominator of 5, you're going to multiply by 5. And x equals negative 15. And to check, negative 15 divided by 5 is negative 3. And negative 3 plus 9 does equal 6. This one's a little bit different. In this equation here, the d minus 2 is actually all in the numerator. So that's considered a set of brackets. So you have divided by 3, and you have brackets. So if we're doing the order of operations, or BEDMAS, but in reverse, the multiplication actually comes before brackets. Or sorry, the division comes before brackets. So we actually need to get rid of the denominator of 3 first. And in order to do that, we're actually going to multiply by 3. And you're going to be left with d minus 2 is equal to 21. Now you can deal with this subtracting of 2. So add 2 to each side, and d is going to equal 23. And to do your check, 23 minus 2 over 3. Again, a numerator is considered a set of brackets, so if you do that first, you end up with 21 divided by 3, which is in fact 7. Double check your numerator. In this case, only the a is over the 7, so we can deal with the 3 first. So to get rid of a positive 3, you're actually going to subtract 3 from either side. And you're going to be left with a over negative 7 is equal to negative 5. To get rid of a denominator of negative 7, multiply by negative 7, and a is going to equal 35. To do your check, 3 minus 35 over 7, does that equal negative 2? 35 divided by 7 is 5, and 3 minus 5 is in fact negative 2. Try these ones, so pause the video, and then once you're done, start the video up and check your answers. So this first one, we're going to subtract 16. 51 minus 16 is 35. And if you divide by 5, z will equal 7. Start with the negative 8, so add h to each side. So 14n is equal to 42. And if you divide by 14, n will equal 3. This is all in the numerator, so that's considered a set of brackets. So the first thing you actually have to deal with is the negative 2. So multiply by negative 2, and what you do to one side, you do to the other. So 4b plus 8 is equal to negative 20. Now deal with the positive 8 by subtracting 8, so we get 4b is equal to negative 28. And divide by 4, and you end up with b is equal to -7. Here's a PAT question. We're actually going to skip this one because this is a lesson 5 question where there's variables on both sides. But we will do this one. So x over 5 plus 1 equals 26. So deal with the positive one first by subtracting 1. So x over 5 is equal to 25. And then multiply by 5. 25 multiplied by 5 is 125. And that would be your answer. So if you filled that in, you do 1, 2, and 5. And that would be your answer. And you've got classwork on page 14, 15, 16, and 17.